Okay, this is going to be a quick video walkthrough for problem 346. We're going to focus on B, but in order to focus on B, we're going to have to walk through A, I think, just to set it up, all right? And so let's talk about both parts of this. What I am going to do is we'll set up A, and then we'll get to B. We will talk about the area and perimeter of one figure, and then I'll leave you kind of with how we went about that and kind of the process to go about finding the area and perimeter for one figure. And then it will be a very similar process to find the area and the perimeter for the second figure. And so you can kind of run with that process and challenge yourself and try to, apply it on that second figure. So here we go. What this problem says is plot, these 5 letters formed by the points A, B, C, D, and E onto graph paper. And so that's what I have above here. Let's graph these real quick. And so I'm going to draw myself a grid or a coordinate plane. And then I'm just going to start putting dots at the locations where they say A, B, C, D, E, and E are. And so A is at -3, -2. And so that is down there. B is at 5, -2. Should be about there. And again, this is A, B. C is at 5, 3. So a little bit above where point B was. Point D is at 1, 6. It's right here. Ooh, 1, 2. Right here. And then our last point is point E, and that's at -3, 3. So E is a little bit above where point A was. And so once we plot all those points, we can connect the dots, and let's see what shape we have. All right, so this is a 5-sided shape. So the fact that it's 5 sides makes it a pentagon. I kind of think it looks like a house, I guess. So I might call it a pentagon, I might call it a house. But that's the shape we're working with. Again, it has 5 sides, so technically it would be considered a pentagon. All right, so part A says use the method from problem 3.2 to enlarge it. And there are a couple pieces here that are important. Enlarge it from the origin, and then, of course, by a factor of 2. Right, by a factor of 2. And then we'll label our new shape with A, B, C, D, E prime, right? And so let's do this. And again, the 2 key pieces here are we need to enlarge it from the origin, and then, of course, specifically by a factor of 2. So let's talk about the origin real quick. Every time we do, this is called a dilation. When we make a shape bigger or smaller, it's called a dilation. And there's always a reference point for the dilation. And so the reference point in this problem, again, is going to be the origin. Remember, the origin is where our x and y axis come together. It is at the point 0, 0. And so that is going to be the center of our dilation. And here's kind of how it works. A dilation makes things either bigger or smaller. And so since we're going to dilate it by a factor of 2, what that means is we are going to make it bigger, and specifically we are going to make this next shape twice as big. But again, there's always a reference from where we make that happen. And here's what I mean. I am now going to connect, we'll just go in order, so we'll go with point A first. I'm going to connect our origin and our point A. And when we connect these 2 things, you'll see I've got that diagonal pink line there. And basically the idea here is I need to figure out, copy that, how to double the distance of that line. However far away point A is from our origin, since we need to make it increase by a factor of 2, we want our new point, which in reference to A would be A prime. So we would want our new A prime to be twice as far away from the origin than our original point A was. And so again, I copied that, and the reason is if I paste it on there and I connect it, you can see, right, we need our new point to be here. That would be twice as far away, again, from the origin as our original point was. However, me just doing it in that way, that's a little bit cheating, right, because I have just better technology, I guess. And so here is kind of the process that you can use by paper or pencil, like by hand, or any of them. All right, so from the origin, what we want to do is let's follow our grid lines. So I went left and down, and I went left 3 and down 2. So if I want to double that distance, I should double those distances. So going left and right, that's horizontal, right? And that's what the 3 is. Going up and down, that's vertical, and that's what the 2 is. And so obviously I am showing vertical and horizontal distances here. instead of diagonal. But if I double the vertical and the horizontal distance, I am in fact also doubling the diagonal distance. And watch what I mean. So again, those distances are 3 and 2, right? So let's say I double that, then it should be 6 and 4. So instead of going left 3, now I'll go left 6. Instead of down, and then instead of down 2, so here's 6, So 3, here's 6, and then instead of down 2, we'll go down 4. Again, what I did was I doubled my horizontal and my vertical distances. They were originally 3 and 2, but if I double 3, now I go 6. And then if I double 2, now I go 4, right? And when I doubled those distances, look at where it brought me. It brought me directly to that dot that I had already put there, right? It brought me directly to the dot that I got when I truly doubled my diagonal distance. But again, we kind of just analyze the vertical and the horizontal distances here. And so I'm going to clean this up real quick. If I don't clean this up each time, this graph gets really messy. But that's exactly what we're going to do for all of these points. And so this new one we'll call A prime. And so now let's go do it for B. And I'm actually going to start color coding it a little bit better. So for B, we had to go 5 to the right and 2 down. So again, we want to double that, right? And so instead of 5 to the right and 2 down, we'll now go 10 to the right, 5, 6, 7, 8, 9, 10, and 4 down. And then we can put our dot. And again, that was from point B, so now we'll call that B prime. And then I can clean these up again. And so again, then we'll just do it to C, D, and E. And so to get to C, we got to go right 5, up 3, so 5 and 3. So let's double those. And we will go right 10, 1, 2, 3, 4, 5, and then up 6. And that should be that point right there, C prime. And then we'll do the same thing with D. So for D, again, we went over 1, up 6, so 1 and 6. So for our new one, we will go over 2 and then up 12. So 7, 8, 9, 10, 11, 12. And there's our new dot. We can clean that up. And then, of course, that would be considered D prime. And then the last one is E. So over 3, up 3 to get to E. And so we'll want to double that. And so we'll go over 6, up 6. And there's our E prime. Again, I can clean this up. And now that I've done it for all 5 original points, right? Now look, I can connect these dots. And it's going to turn out that I have exactly the same shape, but now it's bigger. And not only just bigger, but it's 2 times as big, right? Each side is 2 times as long now. Each side is 2 times as long. And once again, although it's not that hugely important anymore, but we made this happen based around this reference point at our origin, right? Okay, so that is part A. And that brings us now then to part B. And so now we want to find the area and perimeter of both figures. And so I am going to help you find the area and perimeter of the blue one, and then you would find the area and perimeter of the pink one, or it's probably pencil color, for yours. But you can test yourself and find the area, the perimeter of that larger shape. It's going to go through kind of the same process. So here we go. All right, let's start with area. If we want to find the area of this smaller blue pentagon or house, right? We want to the first thing we've always done is we've thought about the shapes we have. We've thought about the formula for area for those shapes, and then we try to just find that information and plug it into the formula, right? But the only problem is we have never talked about finding the area of a pentagon. We have never talked about finding the area of a pentagon. We have formulas for parallelograms, trapezoids, triangles, rectangles, squares, and so on. But we have never talked about an area for a formula of a pentagon. And that's because there isn't just one necessarily. It depends on what the pentagon looks like. But one thing we should notice here is just because we don't have a formula for it directly, we do have the ability to break this shape down into other shapes. right? And so here's kind of what I mean by that. If we look at our pentagon here, our little house, in green, what I am doing is I am showing you that the bottom of this pentagon or the bottom of this house is just a rectangle, right? And so we can definitely find the area of that rectangle. And then if we look at the top of our pentagon is just a triangle, and we can definitely find the area of that. And so what we're going to want to do here is we're going to want to find the area of this rectangle on the bottom. We're going to want to find the area of the triangle up top, and then we just add the two together, and we've got the total area of our pentagon. And so let's work on the rectangle. That one's pretty straightforward. Area of a rectangle, I'll kind of do this off to the side. Area of a rectangle is just base times height. All we need is base times height. Just remember that base and height must always meet at a 90-degree angle. Now that automatically is happening here in our rectangle, so we don't really have to worry too much about it. But let's just remember that that's important. And so our base, we would consider like the bottom of this rectangle to be the base. And so let's count these units. And that is 8 units long for our base. And then our height would be like how tall the rectangle is, right? 3, 4, 5. And so, oops, I wrote 4, but it's definitely 5. That is 5 units tall. And so we can find the area, again, by just doing base times height. And so that would be 8 times 5, and 8 times 5 is 40. Now, I don't want to lead you wrong. I generally check everything on a calculator, so I'll just double check. 8 times 5, yeah, it is 40. Now, normally we would put units on the end of that, and we will, but we'll save it till the very final answer once we get the triangle added in there, okay? All right, so that's the area of our rectangle. Again, that's kind of the bottom part of our pentagon, of our shape. And so now we got to find the top part of it, the triangle piece, and then we can add the triangle and the rectangle together to get the total. And so let's work on the triangle. Now, one thing that's pretty nice about the triangle, well, actually, let's just start with the area again. Right, we want pretty much all this time, we always think about, okay, what's our formula? So area is base times height divided by 2 for a triangle. Area of a triangle is base times height divided by 2. And so that's generally where we're going to start. That's our formula. So what we're going to need is to figure out our base and our height. The base is pretty nice on this because you'll notice that this triangle is just as long as our rectangle, right? And so if we just count those units again, and you don't even hardly have to count them because you see the 8 on the bottom. It is just 8 again. So the base of our triangle is 8. Now, the trickier part is figuring out the height. But remember, your base and your height always form a 90-degree angle with each other. And so as we look at this triangle right now, we don't see a 90-degree angle. But remember, a lot of times we draw our height kind of like as an imaginary side, right? It connects the top part of our triangle to the part that we've identified as our base. And so see, I just drew a red dotted line right from where point D is at the top, right straight down the grid lines to hit with our base. That's going to be what we consider our height, right? Because from the base to that top point D, that's the highest this triangle gets. And so that should be our height. And then because we know that line is perfectly vertical and the base down there where our 8 is, that is perfectly horizontal, those have to form our 90-degree angle. And so awesome. So we got our base, that is 8. If we just count these units here for our height, you'll see that that is 3. And so our base is 8 and our height is 3. And so that's what we will use for our formula over here. So base is 8, height is 3. That'll tell us it's 8 times 3. But then, of course, with the triangle, we got to divide by 2. So 8 times 3 is 24. Still got to divide by 2. And then 24 divided by 2 is 12. 24 divided by 2 is 12. And so our overall triangle area is 12 units, and our overall rectangle area is 40. And so then for our area, we'll just add those together, right? Total area is going to equal 12 plus 40, and 12 plus 40 is 52. And then here's the part where we should add our units in. And they didn't give us any units like feet or centimeters or miles or anything like that. So we'll just say 52 units squared. 52 units squared. And so that's the area. And I am going to actually bring that down low. Oops. because I want that answer down here. Because I'm going to, obviously I've done a lot of work here, and now we're going to start talking about perimeter, and I'm going to kind of erase some of the stuff we did to make it a little bit clearer to do our work up here. But again, once we found the area of our triangle and our rectangle, we just added them together to get our total area, right? And you'll do the same thing on the bigger pentagon as well. All right, so now let's talk about perimeter. And perimeter can get kind of challenging. Part of it in this problem is pretty straightforward. The other part, you got to kind of think through your toolbox a little bit. And so let's talk about that. Again, I'm going to clean up some of this, but I will leave the sides kind of boldened. All right, so here we go. Again, we are working on this, now it's green and purple, but pentagon in the middle of the screen here. And again, we're working on perimeter. And so perimeter is, if we know the distances of all the sides of this pentagon, we're just going to add them together. And it's the total distance around, right? And so again, many of these sides, it's actually pretty easy. The left side and the right side and the bottom side, right? So we're talking left, right, and bottom. They all just follow the grid lines. And so we can just count those boxes. So on the left side, it's 2, 3, 4, 5 units. I think you can tell the left and the right side are both the same. So on the right side, it'd be 5 units as well. And then on the bottom, and we've already counted this before, right? It was the base of our rectangle and triangle. That is 8 units. And so we've got 3/5 of the house done, 5, 8, and 5. But the tricky part now is focusing on kind of like the roof, right? The roof of the house. And so here's what we have to do. And we actually kind of set up the plan. I'm actually going to erase these. We actually kind of set up the plan a little bit earlier. The reason why this part is a little bit trickier is because that roof is slanted, right? It doesn't follow any grid lines. And so we can't just count boxes or count lines to be able to figure out how long they are. But we do have another tool that we introduced about a week and a half ago. And it's this. If we put if we kind of highlight here, and maybe I should even do it blue, that'll make it match. If we kind of put, the top of this rectangle back in, top of the rectangle, or more importantly, it becomes the bottom of the triangle, you'll see that we have a triangle here, right? And triangles can be really, really useful in finding distances on grids or on coordinate planes. And the reason is this. Remember, we had our height drawn in here. And when we draw our height down, we actually end up with 2 right triangles. And I'm going to highlight this real quick, but then I'm going to erase it. But our 2 right triangles are here. We've got this orange one on the left, and then we got this pink one on the right. When we drop that height down, it actually turns that entire top of our pentagon into 2 right triangles. And I say right triangles again because of this 90-degree angle. Now, not only 2 right triangles, but 2 congruent right triangles. Remember, congruent means that they're exactly the same. And here's why they're exactly the same. You can see both of these right triangles, the orange one and the pink one, share the exact same height, right? They share the exact same height. That is that dotted line right down the middle. And so that height is 3. And again, both of them share that height, 3 units long. And then we know the total base on the bottom is 8, right? But if we only look at half of this triangle at a time, so from one edge to where our height is, that's 4 units. And then for our pink one, 1, 2, 3, 4, that's 4 units as well. So again, when we drop that height down, it split this entire top triangle into 2 congruent right triangles. And again, we say they're congruent because they both have the same height, which is 3, and they both have the same base, which is 4. Now I'm going to start clearing them up because this is going to be where we have, where we kind of got to dig into our toolbox, and we got to remember that if we know 2 sides of a right triangle, we actually can solve for the third one. Now again, 2 pieces are important there. You need to know 2 sides, and you're only missing 1, and then the other thing is it had to be a right triangle. And so that's why I redrew the height here, because we created right triangles. But when we do that, when we have a right triangle and we know 2 sides and we're only missing 1, we can always solve for the third side using the Pythagorean Theorem. Our a squared plus b squared equals c squared, right? And the trick to the Pythagorean Theorem is just knowing how to label c. C is always our longest side, and not only is it always our longest side, but it always occurs across our triangle from our 90-degree angle. So that kind of looks like this. Find your 90-degree angle, draw an arrow across the triangle from that angle, and that will be pointing at your C side. We call it the hypotenuse, and again, it's the longest side of the triangle. So our missing side here, that's what C has to be. And then we know the other distances, right? 3 and 4. And so those are our other two sides. And they would be what A and B are. Now, it doesn't matter which one's A or which one's B. So I just like to go left to right. I'll call 3A and 4B. And so again, we know two sides of a right triangle. We know that one side is 3, the other side is 4. And so we can use that and the Pythagorean theorem up here to solve for that third missing side. And what we'll be solving for is C. And so let's do it. Let's plug 3 in for A and 4 in for B. So instead of A squared, we're going to have 3 squared and then plus. And instead of B squared, we are going to have 4 squared. And that equals C squared. And so let's keep simplifying. And all of these Pythagorean theorem problems are always the same. Once you get things plugged in, start by squaring everything. So 3 squared. And remember, squaring by definition means multiplying by itself. And so 3 squared means 3 times 3, and that is 9. And then 4 squared is 4 times 4, and that is 16. And we still equal C squared. And now we'll add 9 and 16 together. 9 plus 16 is 25. So 25 equals C squared. And then the last step, every single time you do a Pythagorean theorem problem, is we do not want C squared. We want to solve for C. So to undo a squared thing, we want to square root both sides. And then on the right side, the reason why that's important is because square rooting a square, those things just cancel each other out. So the squared and the square root cancel each other out, and it just leaves us with C. And then what you want to put into your calculator is the square root of 25. And a lot of times when you put a square root into your calculator, you get a decimal out. This problem's really nice. The square root of 25 is just 5. And so that's what C is. And remember, C is the length of the missing third side, which is also the length of that slanted side of our pentagon. And that's what we want, right? And so that is 5. And then we had this conversation already, but remember when I dropped that height down into my triangle, it created 2 congruent triangles, meaning 2 triangles that are exactly the same. So if the slanted side over here is 5, the slanted side over here is 5 as well. And now we've got all of our pieces. We got the 2 5s up top, 5 on the side, 8 on the bottom, and other 5 on the side. And so our perimeter then is going to be adding those all together. We'll go 5 plus 8 plus 5 plus 5. And when you add all that up, it should leave you with 28. And perimeter is just regular units, not square units. So we'll say 28 units. And that is our answer there. And so again, let me drag that a little bit further down the page. That's the perimeter. And so that answers the question, for the little shape on the inside. And so what I just would like to challenge you to do then is to take that information and try to figure out, perimeter and area of the bigger shape, the one that we dilated to be twice as big. Again, that is the pink one on this screen, all right? Awesome. So thank you very much. I hope this helped. Have a great day.